Moving on to example 4 and 5, which both involve graphing exponential functions when our a value is not 1, which pretty much is the same thing as before. We just have to do one more step with our 3 points that we graph each time. Other than that, it's the same as last time. So, if you notice, our a value is not 1 anymore. So, this equation, f of x, remember, can be rewritten as a y. Our a value is the 1/3, and our c value, the number with the exponent, is the 2. So first, our growth and decay, you do the same thing as before. It involves the c value. So our c value, the number with the exponent, is a 2, which is greater than 1. So holy hot dog, this is going to be a growth. So I already know when I graph this thing, it should be increasing from left to right. Okay, and then my 3 points. So this is a part where it's slightly different. Okay, so 0, 1, we already know that's 0, 1. Okay, which I'm just going to rewrite it again. We're going to be doing something with these 3 points in just a moment. So that's why I'm not plotting them yet. Okay, now my 1c. So my c value, we said, was a 2. So this is going to be a 2. And then at -1, remember we find the reciprocal of 2. So remember, 2 can kind of be rewritten as 2 over 1. Okay, so this is like 2 over 1 for my c. Okay, and if we find the reciprocal of 2 over 1, it turns into 1/2. So at -1, the y value is 1/2. Now, this is the part that is different. So, when you have an a value, okay, you keep the x's the same. Leave your x's alone. So I'm going to go ahead and rewrite my x's. I'm not changing those. But something is going to happen with my y values. So I'm going to write my y values, but we will be doing something with the y values. So I have 1, I have 2, and I have 1/2. Hey, when you have an a value, you have to take the a value and multiply it to all of your y's. Kind of like we did when we did transformations with absolute value functions. Okay, when you have that a value, okay, we have to multiply it to our y value. So I'm going to take all my y values and multiply them by my a value, which is 1/3. Okay, which I'm going to rewrite my previous y values as fractions, so it kind of makes it easier to multiply with fractions. So remember, when we multiply fractions, we go straight across. So my first point, I'm going to write the points down here because I'm kind of running out of space. My first point, the x value is 0. And my y value, 1 times 1 is 1. And 1 times 3 is 3. So my first point is at 0, 1/3. So I'm going to plot that real quickly. And remember, you just kind of approximate when it's at a fraction like that. So 0, 1/3. So that's about 1/3 of the way up. Looks pretty good. Alright, my next point, I leave the x alone. So my 1 stays the same. Now my y value, remember, you go straight across when you multiply fractions. So 2 times 1 will give me a 2. And then 1 times 3 will give me a 3. So this is 1, and then it's 2/3, which is a little bit higher up than 1/3. And I also know it's a growth, so I know it should be increasing. So I'm going to put that about another 1/3 up from this point. So about right here. Looks good to me. And then my final point, my x stays the same, so that's still a -1. And then my y value, remember when you multiply fractions, you just go straight across. So 1 times 1 gives me a 1, and 2 times 3 gives me a 6. Okay, so 1/6 is smaller than 1/3, and since we know this is a growth graph, we know that it should be increasing. So I know this point should be a little bit lower than this one. So I'm going to go down. 1/6 is actually half of 1/3, so I'm going to put it in between the 0 and that point right there. So I'm just going to put it like right there. That looks good. Alright, so those are my 3 points that I just plotted right here. I'll box them if that helps you to see them. Use a different color. That's 1, 6. Sorry, I cut it off on accident. Now the asymptote equation, just like before, it's always the same thing in these problems. It's always the x-axis, which is at y equals 0. So that's our x-axis. So I'm going to draw that in real quickly before I finish drawing my graph. Alright, so I'm going to connect my points. I'm going to start here and go up. And then on this side, I'm going to get really close to the x-axis, but I will not touch it. So that is our amazing graph, and I'm going to call this thing, let's see here, I'm going to call it Nelly. Nelly the exponential. Alright, last up is domain and range, which, if you notice, it's always the same thing. So our domain, we asked ourselves, how far left does it go? Which this graph heads off in the negative infinity direction for forever. Then we ask ourselves, how far right does the graph go? Which it does get wider and wider, so it heads in the positive infinity x direction. Okay, which that's interval notation. Inequality notation, since we go from negative infinity to positive infinity, would be x is all real numbers. Okay, so that's our domain, which it's just like example 2 and 3 for domain and range, same thing. Alright, and then the range is the y-axis, so you ask yourself, how low does the graph go? Okay, which it goes really close to 0, but does not touch it. So I'm going to put that 0 in a parenthesis, because it cannot equal it. And then you ask yourself, how high does the graph go? Which it shoots off in the positive infinity direction. And it cannot equal it, so we leave it as a parenthesis. And remember, the way we write this, it involves the y's, because range is the y-axis. It involves a 0, and these numbers up here are larger than 0. So y is greater than 0, but it cannot equal 0 because that asymptote is in the way. So that would be the incredible graph for this exponential equation. Now example 5 is basically the same thing as this one, just slightly different. So if you want to try example 5 without my help, go ahead and start the problem, fast forward it to the end, and see if you did it correct. Have fun, you guys.